This is question 6 on chemistry from the 2018 BMAT. So we're given a diagram of the apparatus for fractional distillation, which looks like this, and we're asked which statements are correct about it. So covalent bonds are broken at position 1 here, and reformed at position 3. 2, the particles are closer together at 3 than they are at 2. And statement 3, there is an exothermic change in the process that happens at 1. So let's look at statement 1 that says covalent bonds are broken at 1 and reformed at 3. Is this correct? Well, let's take a look. So at 1, we've got a mixture of liquids that we're heating, so clearly that's evaporating into a gas, and 3, the gas is being condensed by this cold water back into the liquid. So have covalent bonds broken and reformed? Well, if we take a liquid and we boil it into a gas, what's happening? Well, we're not breaking covalent bonds, we're just breaking the intermolecular forces, which could be van der Waals or hydrogen bonds. And we know that the covalent bonds are only found on the internal structure of each of these molecules, so none of these are changed. Covalent bonds aren't broken or reformed, so we can say statement 1 is wrong. Next, statement 2 tells us the particles are closer together at 3 than they are at 2. Is this correct? Well, what's 2? 2 is when it's in the gaseous state, and 3 is when it's condensed back into the liquid. So 3 to 2 is the reverse of this process, where we're condensing the gas. So we can see by inspection the particles are far closer together in a liquid than they are in a gas. So statement 2 is correct. And finally, statement 3 tells us there's an exothermic change in the process at 1. Is this correct? Well, we already found out that what's happening at process 1 is we're breaking the intermolecular forces in the liquid to form a gas, and that's all that's happening. So do you think this is endo or exothermic? Well, we know that breaking bonds or intermolecular forces requires energy, and forming bonds releases energy, and it's the balance of these two that decides whether it's endo or exothermic. So which one is this? All we're doing is breaking intermolecular forces, or let's call them bonds, and this is an endothermic process because we have to put in heat for this to happen. And we know this is true because when we sweat, we release a liquid which evaporates, and this cools us down. And we know endothermic reactions cause the system to cool down. So we can say this last statement is wrong because it's endo rather than exothermic, and this corresponds to answer C on the question paper.